Welcome, my name is Scott Baker. This tutorial is one in a series of tutorials about the Raven provisioning service for Genie. This particular tutorial will focus on using the Kong Experiment Control Service, which is a subservice of Raven. For more information, please consult our website at raven.cs.arizona.edu. In the previous tutorial, we showed you how to use the Raven tool to deploy RPM packages to your experiment. We also built and deployed a custom package called Hello World. If you haven't done that tutorial yet, please go back and do it, as that tutorial includes several necessary steps, such as setting up an experiment container and installing the Sface tools. In this tutorial, we're going to build an all-pairs ping experiment. This experiment will be called pingpong. There'll be two components, a pong component which listens for packets and then sends them back to where they came from, and a ping program which sends out packets. We're going to deploy pingpong, and we're going to control pingpong with our Kong Experiment Control Service. So Kong is designed to control your experiment. There's three main functions to this. One is to distribute data. So one thing we found is that many experiments need to distribute small bits of experiment state between all the nodes. In our case, with the ping-pong demo, that bit of data is going to be a port. Each member of the experiment is going to listen on a particular port, and the other members will need to know what that port number is so that they know which port to send their ping packets to. The second main function is to control experiment state. So we've divided an experiment into four primary states. There's a prepare state, which is where your experiment will make itself ready to be run. So in our case, the prepare step will be to get the Pong service running up on all of the nodes. Once an experiment is prepared, the next step will be to run it. Once you enter the running state, the experiment is actually being conducted. So in our case, that's going to be sending ping packets to the Pong program, waiting for the Pong program to respond. There are also various reset states. For example, you might want to terminate an experiment early. And there is an opt-out state. Opt-out is what happens for nodes that are not in the experiment. So for example, you may only want to run an experiment on 5 nodes, but your slice may have 10 nodes. The nodes that would not be participating, you would put in the opt-out state. And finally, the last main function of Kong is to collect results. So similar to the way the membership variables worked, there's also result variables. For result variables, you create a file in a directory, and Kong will automatically read the contents of that file and present it back to the administrator on the console of the Sface tool. So that is a very convenient way to collect the results from your experiment. In our case, we're going to be returning the ping times from our ping pong experiment. The main mechanism that Kong uses to control your experiment is some scripts that you will be responsible for deploying on your slice. These scripts are contained in etccong.d, and there's two different kinds of scripts. One is an experiment control script, which is a script that Kong will run to cause your experiment to do a particular thing. So there's two of these that most people need to be concerned with. There's a prepare script and a start script. The prepare script will cause your experiment to enter the prepare state. So inside of that script, you would do whatever actions are necessary to prepare your experiment for running. Then the start script would start your experiment. In our case, that's going to be to start sending out pings. In addition to those two scripts, which are used for Kong to tell the experiment what to do, there's also some scripts where the experiment tells Kong what has been done, and that's these experiment status scripts. So there's a prepared script, which you can execute from your experiment to let Kong know that you finished preparing, and a complete script, which you can execute to let Kong know that the experiment is completed. These two scripts go hand in hand with prepare and start. So for example, a typical experiment inside of its prepare script would do all of the steps that are necessary to get the experiment ready, and then it would execute, as the final line of the prepare script, it would execute the prepared script. The start script would typically run an experiment, and as the final line of the start script would execute the complete script. And then there's also the opt-out script, which is used if a node wants to opt out for any particular reason. So inside of the prepare script, You could determine that your node has some kind of problem. For example, maybe its disk needs to be cleaned, or the load is too high, or for some reason you don't want that node to participate. In the prepare script, you could call the opt-out script, and that node would automatically be opted out of your experiment. Finally, there's a set of Kong variables. These compose the membership and result variables. So some variables go in the direction of from the experiment to the Kong service. Some go from Kong to the experiment. So in the experiment to Kong variables, we have a directory called var Kong results. And what you do is you put text files in there named after your variables. So let's say I wanted to create a CPU benchmark variable. So inside of var Kong results, I could create a text file called CPU bench, and inside of it I could put, for example, the number of prime numbers computed per second, or some interesting CPU metric. That result would be collected and displayed to the user in the Kong user interface in the Sface tool. Now, a special subset of the result variables are membership variables. These membership variables start with the 4 letters MEM underscore for membership. And what Kong will do is during the prepare phase, whatever you put in these membership variables will automatically be redistributed to your other nodes. For an example, with our pingpong program, we want to communicate port numbers to the other nodes, so we will create a variable called mempongport. We will put the port number that Pong is listening on in that, and Kong will pick up that file from each node and distribute it to all of the other nodes so that all of the nodes can be aware of each other's port numbers. Now, in addition to the experiment to Kong variables, there were some Kong to experiment variables. And the primary one of those is called var Kong members. Inside of this directory, Kong will create a text file for each node that is a member of your experiment. For example, if planetlab2.cs.uoregon.edu was a member, there would be a text file in there called planetlab2.cs.uoregon.edu. So just by looking at the names of these files, you can discern the members of your experiment. If you look inside of the files, you will conveniently find all of the membership variables. So if you created a membership variable on planetlab2.cs.uoregon.edu for the Pong port, it would show up on the planetlab2.cs.uoregon.edu file in the var Kong members directory of every member in your experiment. So that is it for the introduction. Let's get started using the tools. Let's start by going back into our experiment directory, which was called My Experiment. So let's take a quick look around. We'll see one of these directories was the build directory, which is where we put packages to build. We want to go back in there again. So let's go back into build. Look around the build directory. We can see the Hello World app that we built previously is still here. But what we want to do is create a new app called pingpong. So we'll make a pingpong directory and go inside of the pingpong directory. Now I want to install my pingpong files in user local bin. So I will create a user local bin path and go inside of that path. And I've already created, outside of this demo, my ping and pong programs. So I'm going to copy them in. And I'm going to set both of those scripts to executable so we can run them. Now let's take a quick look at our scripts. So let's start with Pong. Pong is the program that is responsible for responding to ping. So what we're going to do is we're going to run Pong on our nodes, and Pong will sit there all of the time waiting for packets to show up on a predetermined port number. Whenever a packet comes in, it will respond to that. So let's look at what it actually does. This Python program. First thing it does is just some sanity checking to make sure that some important Kong directories are existing. Then it creates a socket. It binds the socket to an anonymous port. And then down here, this is an important step, it writes the port number that it bound the socket to a file called var-cong results mem-pong port. So any Kong variable that starts with mem is considered a membership variable, and whatever you write there will be reflected to all other nodes in the experiment. So by writing the port number to that file, their ping programs can find out the port number and know which port to send their pings to. And then we have a simple while loop down here that waits for packets to come in, prints something to the screen, and then sends a packet back out to the address it came from. More complicated is going to be the ping program. Let's take a look at it. And ping starts with this helper function called load members. So one of the nice things about Kong is that it automatically maintains membership information throughout our experiment. So by looking in the var-cong members directory, you can see which other nodes are members of the experiment. There will be one text file in that directory for each node that is a member. So for example, there might be a file called planetlab2.cs.uoregon.edu if that particular node was a member of our experiment. Inside of each of these files, it's a text file, and each line is a name, the equal sign, and a value for various data about that node. So this load members function here, it opens up those files, parses them, and puts them in a Python dictionary. So we can see going down to main, the first thing it does is load members, and that is to figure out which are the members of the experiment. Then it creates a socket, sets the timeout on the socket to 30 seconds so we never wait forever for a response, generates a sequence number. So let's take a look at the two main loops in here. The first main loop is to send the pings. So what we're going to do is we're going to iterate through all of the host names in that membership dictionary that we constructed in the load members helper. For each host name, we're going to extract the mem-pong port, which was the port that we want to send the packets to. We construct some payload that we want to put in our packet. We build up the address, which is the host name and the pong port, and we send that packet out there via UDP. After we've sent everything, then we're going to wait down here in a loop that waits for responses. So what it does is it sits here receiving UDP packets. For each packet, it unpacks the payload, extracts the host name, computes the elapsed time from the time we sent to the packet to the time it returned, verifies the sequence number is correct, so we are not getting data from a previous iteration of the experiment. And then it updates the member dictionary with these values. And finally, down here, it creates a file in var-cong results based on the host name, writing the elapsed time to it. So one of the things that Kong will do is it will take and collect everything that is in var-cong results and present that back to the user. So this will be our primary method of data collection. We're back in the root. Let's go into the Kong directory. So inside of the Kong directory are a couple of config files. The config files are automatically generated, so you do not need to edit them, and a bunch of scripts. So these scripts will be used to start various actions in your experiment. So what's really important to us is the prepare script and the start script. The prepare script will be used to set up the experiment so it can be run. In that, we're going to want to, for example, start Pong on all of the nodes. And then the start script will run the experiment. And in our example, that will be to run ping to contact all of the Pongs. So let's start by taking a look at prepare. So as we can see, it's just a stub of a script. There's a blank section here where you're supposed to do your experiment stuff. And then finally, when your preparation is completed, when this node is actually ready to do the experiment, you run this prepared file, which will notify Kong that the node is ready. So we want to customize this. So let's delete the comments in the middle. And the first thing we want to do is to make sure that no instances of Pong are already running. So if there is an instance of Pong, let's kill it off. Then we want to actually run Pong. So we're going to use nohup to run it. And make sure we pipe its output to dev null and run it in the background. But we'd like to make sure before we tell Kong that we're ready to go that the Pong daemon has actually got to the point where it's written out its membership variable and opened up its port. So we'll put a little while loop here. And we'll wait for that mem-pong port file to be created. If you recall, that was one of the last steps that the pong.py program did before it started the main loop of waiting for packets, was to write that file. So we're done with the prepare script. Let's look at the start script. This is also just a stub for a real experiment, so it's just got comments in the middle of it. And you'll see, like the prepare script, it has a little thing at the bottom which calls the complete script to tell when the experiment is actually completed. So let's delete the boilerplate out of the middle. And we'll start by killing any instances of the ping program. There shouldn't be any running, but just in case there are, let's make sure they're gone. Now, what I'm doing here is I'm checking the membership to make sure that this node is a member of the experiment. Kong automatically maintains membership information for us. Recall there was a varkong members directory that listed all of the members in an experiment. To make it easier for a node to tell if itself is one of those members, Kong will create a file called varkong self member. If that file exists, then this node is a member of the experiment. If it doesn't exist, then this node is not a member of the experiment. And at this point, the node should opt out. So by doing that, it runs a file called opt-out, which will tell Kong that the node has safely opted out of the experiment. Then it exits this script. The next step is going to be to run the ping program. So we're going to run user local bin ping, and that will execute the ping program, which will send out all of the pings, wait for the responses. You'll notice we didn't run it in the background as a daemon. We actually ran it such that it will need to finish before it can continue the rest of the script. When it finishes, then we will go down here and we'll run the complete script, which will tell Kong that the experiment did finish. So this is just one way to run a short-term experiment. If you had a long-term experiment, you would probably, for example, want to run ping in the background. So we're done editing this file. Let's save it. And now we're ready to publish our experiment. Let's go back to the Kong graphical user interface. So we have relaunched Sface. We're looking at the test35 slice again, so let's go back into our Raven tab. We see that we still have CPU bench, GNU chess, hello world, all those things. Let's click the publish button. And if we scroll up in here, we can see that a new package was built called pingpong. It's automatically versioned to version 0.1. That package is being uploaded to the Raven repository, as well as a new Raven config RPM. It automatically knows that it's already uploaded CPU bench and hello world, and it's also uploading a new start config file and a new TP file. We go up here and we click refresh. We can see that pingpong is now on our list of packages that are allowed in our experiment. Now we'll just give it some time and wait for that package to be deployed on our nodes. While we're waiting for the package to be deployed, let's take a look at the Kong tab and see how the Kong service is set up. So we have here is we have a list of nodes that are participating in the experiment. We also have some configuration so we can set the minimum and maximum number of nodes that we want to participate in the experiment. And we have a bunch of buttons that control state. So we can push the initialize button, would make our experiment initialize. Prepare would cause it to enter the prepare state. Run would enter the run state. And reset would reset our experiment back to its initial uninitialized state. There's also an automatic mode which will do an automatic sequence of initialize, prepare, and run, and is used for short-term experiments when you want to run a quick run of them. So one important thing about these states is that they do have to be operated in sequence. For example, you cannot go from the initialize to the run state without first going through the prepare state. There are some nodes that have been frequently in contact. So for example, this one was last in contact about 1.5 minutes ago. This one here, 51 seconds. There's some with some very large numbers, They are probably nodes that have been rebooted or otherwise dropped out of Planet Lab. Either that or they're running slowly or they have a traffic problem getting the UDP packets to those nodes. So shorter numbers indicate that the nodes are actively participating and updating their state. Long numbers indicate nodes that may have problems with. Let's try pushing the initialize button and see what happens. So we can see the server state went to initialize. That is the state that's being broadcast to the nodes. And several of the nodes went into initialized state. That shows that they are ready to enter the prepare state. As we suspected, these two that are lagging somewhat behind have issues. They're still sitting in uninitialized. Let's push the prepare button. Now what's interesting here is we have some nodes that are in a state called missing packages. The missing packages state means that the packages that we've sent to be installed on those nodes have not yet been installed. So for example, one of those packages was the pingpong package. On this node here it's not there yet. On this node here it is there. So what this indicates is that the experiment is not yet ready to be run. So we can go back here, we can click reset and put everything back into the uninitialized state. We've given our nodes about 10 to 15 minutes for all of the packages to be installed, so let's try this again and see if we're in a little bit better state. So we'll push the initialize button. So we see that the server state has gone to initialize. We can see that various nodes are entering the initialized state. We still have a couple nodes that have problems and are lagging out of the experiment. Let's try the prepare button. So we can see that some have entered the preparing state and a bunch of them have entered ready. So all of those ones that were missing packages have now had their packages installed. We can also see in here reported the mem-pong port, which are the pong ports that each node is reflecting to the other nodes. So we've entered the prepared state. Let's click the run button and actually run our experiment. So we can see nodes transitioning from ready to running. There's two of them. There's a bunch of them. There's all of them. So these nodes are right now all conducting their pings. And we just have to wait for them to complete. There we see that some of the nodes have completed. And we will see that the result variables are displayed here in the table. So for example, pl1.eecs.utk.edu was able to ping planetlab1.uta.edu in 44, planetlab2.cs.uoregon in 86, planetlab3.arizona gigapop in 64, and planetlab3.cs.uoregon in 88. And we can see that for each of these nodes that participated in the experiment, similar things have happened. Now if we wanted to, we could reset the experiment so we could conduct another run. See that all of our nodes have gone back to an uninitialized state. Let's try an automatic run. So let me set a minimum nodes. Let me set a minimum nodes to 4 and a maximum nodes to 6 and click the auto button. So we can see it set the server state to initialize, so it's waiting for them to initialize. waiting for at least 4 clients to enter initialize. Then it automatically went to prepare and waited for at least 4 clients to enter prepare, so it managed to get a set of 5 of them. Now that they are prepared, it's telling them to run. You can see up here that they are running. And we can see that they are starting to complete. So now they are all complete. That concludes this tutorial on the Kong Experiment Control Service.